Alright, it's time for the math. Easy solution to discuss. We'll just do some summation examples. In my earlier videos, I did a lot of proofs for summation of cubes and squares and just consecutive integers. Now I'll do some useful examples because this will be useful once we get into integral calculus. And the first example here, basically, example 1, evaluate this summation here where initially I is 1 up to n of I times and then 4i squared minus 3 here. Well, first thing we could do is just simplify this further. This just equals to, just write it there, equals 1. If we just multiply the I inside, we're going to get 4i cubed minus 3i here. And then if you see my rules on summations, you could basically break this apart. So this will equal to, put the 4 out here, put the I3 minus sigma, you could take the constant out of I by itself. I equals 1 up to n here. So you have these two, and then these two summations of these I cubed, and this is consecutive integers like 1, 2, 3, 4, 5. And I showed in my earlier videos on the proofs, you can see in the video link below. This just equals to, well, 4 times, this is going to be n times n plus 1 divided by 2 and then squared. That's for the I cubed. And then minus 3 times, well, this one's just going to be, this is going to be n times n plus 1, and then just divided by 2 here. So it's the same one here, but not squared. So so then we could just use this one here. So this equals to, and we could just break this apart and then sum it up. Or first we could simplify this out. This is just going to equal to, well, n squared, n plus 1 squared. This is going to be divided by 4. So then it's going to be a 4, and then there's a 4 here. This cancels here, minus 3 over 2 and n plus 1. And now we could take out the like terms, and in this case n times n plus 1 is a like term, so just take it out, n plus 1. And now we're going to be left with, on the top here, this is going to be an n. We took one n out, and then there's going to be an n plus 1 left, and then minus 3 over 2. So this is the, that's what we have here. And we could simplify this a bit further, just times by common denominator, or in this case, it's 2 over 2 here, so we could add these up, and then you'll get a final answer of, well, n times n plus 1, and then this whole thing at the bottom is going to be divided by 2, so this is going to be divided by 2, and then if you multiply this 2n times by n plus 1, you're going to get 2n plus, or 2n squared plus 2n, and then a minus 3 on the top here. So this is our answer here. That's the answer. So now if we look at example 2, here's the last example to do for today. Basically, limit as the summation of 3 over n. In this case, we're using n inside the formula. That's okay. Well, if this was 3, this would be a 3, etc. So now of times by I squared divided by n plus 1 here. And this one here, this is similar to the calculations we're going to do in integral calculus when we have to compute area, or area can be also considered sometimes, or an analogy to the integral of a function. So this will be useful once we get to later. Now first thing we do, we just do like before, we just try to simplify this so that we could just have this by the stuff we know, like I squared or cubed or whatever. This was consecutive integers summation. So we could just write it as limit n approaches infinity of this, just write the sigma notation there, and then we just times this inside, so we're gonna get, well, I just want to simplify it further, so 3 times I squared, and we're gonna get rid of this n squared, so this is gonna be n squared times by an n, so n cubed. I just will multiply inside, plus 3 over n here. So we have this one now, and then we could just use our summation rules where we could add up 2 different summations. So this would equal to limit as n approaches infinity of, and then we're gonna have 2 summations in this case, but we could take out all of these constants. N is a constant, but it just depends on whatever this n is you choose. So basically you take it out, n to 3, so we're gonna have 3 over n cubed, and sigma notation I equals 1 up to n of I squared, and then plus, we'll take out the 1 over n to 3 actually. So we took out 3 and that as well, and then we're just gonna have a summation of 1 here, as I equals 1 up to n, and this one here, this one number is just gonna be 1 plus 1, etc., all the way up to 1, and it's just n of these. And so it's just gonna be n times 1, and it's gonna be n. So this summation here, this just equals to, well, n. So we're going to have 3 over n times by n. And then this one here, if you saw my earlier proof on I squared, you can see on the video below, this is a sum of squares. And this would equal to, well, just going to be 3 over n cubed. That's what constant out of there. And this is going to be n times n plus 1 times 2n plus 1 all divided by 6. That's this one here. So now if we put this all together, we're going to get limit as n approaches infinity of 3n cubed, and then this is the I squared summation formula plus 3 times n over n. And now we can begin simplifying. This would just cancel. We're going to be left with a 3. And then this one here, we could rewrite this in a better way. We'll just write it as I'll show you. It's a pretty neat trick. You could break this apart because this is n cubed. There's 3 different n's here, so we could write it as 3 then times it by n divided by n here. We'll just get the 6 out as well, so we'll put the 6 out here. So 3 divided by 6 times n divided by n times it by n plus 1 over n, because we're just separating this n cubed into 3 n's, and this is times it by 2n plus 1 over n here. And then we just add the 3 at the end here. So as you can see at the bottom here, this is just n cubed. This is all just divided by n cubed here, so we're not changing anything. And now we can begin simplifying further. This is going to be equal to limit n approaches infinity. This is going to be a 1 over 2. So this could be 1 over 2 here. This is cancelled, so we're going to be left with a 1. And then here we're just going to have, now we can divide this out separately. So we're going to have a n divided by n, or a 1, plus 1 over n. And then divide this one out. This is going to be a 2, because 2n divided by n is just going to be 2, plus 1 over n, and then plus 3 here. So now we could, just begin applying our limit rules here, or just put in see what. Yeah, and once we apply our limit rules, we'll just see what happens here. So this is going to be equal to, well, the limit of this one here. This is going to be 1 over 2 times 1 here, and it doesn't get affected by any n here. There's no n here. But when you put an n on this case here, this is going to be a 1 over infinity and goes to 0. Same with this one here. This is going to go to 0. So we're just going to be left with 1 plus 0, and then times 2 plus 0, and then a plus 3 here. And then if you simplify this further, 1 over 2 times 1 times 1 times 2. It's going to be 1 times 2 here, plus 3. And this just cancels. We're going to be left with 1. So this equals 1 plus 3 equals to 4 here. So then that's the answer here. So the limit is 4, and this is basically how I'll show you how to do integral proofs for and whatnot using this kind of method here, where you just put in a summation, find the proofs that we use, the summation formulas that I proved, and then use the limit once we break it down and simplify it. Well, that's all for today. Hopefully you learned from this. Remember, you can always download the Dropbox notes, the notes on this on the Dropbox link in the info below, and also all the video links for all the proofs of these the formulas that I use, the summation ones, are also there. Well, thanks for watching, and stay tuned for another math easy solution.